Hello and welcome to the second part of this data processing with Pandas in Python course. Now we're going to start by doing some histograms and then we're going to have a quick look at doing regression and how that looks at in Pandas. But most of today's session is going to be focused on a single piece of project work. I'm going to give you a large Excel spreadsheet of student exam results and I'm going to ask you to process them. I've got a list of questions, imagining that you're the director of undergraduate studies and you have to process this data in a particular way. So that's going to be the focus of the course for today. You'll see that this video is much shorter because I'm expecting that you're going to spend maybe an hour longer on answering these questions. I'm still here on Microsoft Teams in the chat, so if you have any questions, let me know. But if you're ready to kick off and start by looking at some histogram plotting, then let's go. All right, so let's get back up and running. So we need to reopen Jupyter Notebooks, and so you need to do that exactly as you did for the first part of the course. And then if you navigate to the examples folder, if you did exactly what I did in the first part of the course, then you will find there should be, in the examples folder, these Jupyter Notebook files, which are .ipynb. Before they were called Jupyter, they were called IPython notebooks, which is what the IPynb stands for. And you probably want the latest one, but that will depend on you. Maybe you only have one called Untitled, and that's okay. So if you load up the latest one here, then you should remember, you should find everything that we did in the first part of the course. And it'll get down to here. Now, something to note is that if you try to continue directly from here, it's not going to remember what data is, and it's not going to remember what data 2 is. So if you click in the last cell, and if you can go up to cell and then run all, that will run everything from the top of your document all the way down. And there's a little peek what we're doing later. And you can see that you get a bunch of stars, and eventually they will all become numbers, and then you'll be good to go. Now, if you have an error at some point, it's not going to run all the way down. It's going to get down to the error, and then it's going to stop. If that happens to you, say that there's an error here, you can skip past the error. You can click here into the next cell, and you can go run all below. So that should get you all the way down to the bottom. Alternatively, if that's not working for you, you can open up a new Jupyter Notebook, and if you just put these commands in here, matplotlib inline, and then these import statements down here, then you will also be good to go in your new document. Better to, if you can, try and continue from the old document, but if that's not working for you, this should give you something clean and ready to go with some histograms. So if you are ready to do that, then let's go ahead and plot some histograms. If we go to our back to our Jupyter Notebook, just stick in data.hist and be amazed as you get little histograms for all of the columns. There's the mosquitoes, the rainfall, temperature. Okay, they're a bit cramped together. That's just Jupyter Notebook style. But temperature Celsius, which of course is the same, and the year, which unsurprisingly is somewhat flat. We can do better than this though, which is the scatter matrix. I think you're going to be impressed. Now here, I've given the command that you need on the GitHub to create a scatter matrix. Again, I'm going to type it, but you can copy and paste. So from pandas.plotting, you need to import scatter matrix, and then I want you to run scatter matrix with the variables you're interested in. So in this case, it's temperature, rainfall, and of course, mosquitoes. Take a look at this. The first time I saw one of these, I was super impressed. But actually, it's really easy to make. So it's a scatter matrix of every variable against every other variable. But on the diagonals, you have the histograms.
I think this is a really nice way of displaying this data, and you can see there's a nice clear correlation here between mosquitoes and rainfall. In fact, can we be more precise about what that is? We can with the correlation matrix, data.cor. And so you can see the correlation, of course, between everything in itself is always 1, that's on the diagonal. But if you want the correlation between, as we saw here, between mosquitoes and rainfall, 0.998. Pretty convincing, right? So that's the correlation matrix. Can we do something even better though? Say we want to take this correlation here and let's find out what the equation of a best fit line would be that goes through it. Well, in order to do that, we need to do some linear regression. I'll talk about that in just a moment, but first I'm going to let you go ahead and do what I've done here, and then we will continue. All right, so let's play regression. Here's some regression here. So for this, we're going to have to copy and paste this this section here, this bit of code. Once again, you can copy and paste it. I'm going to talk through it as I type it in. So regression isn't in the Pandas box by default. You have to import it from the stats models Python package. There it is. On the x-axis, we're going to pick rainfall, and on the y-axis, we're going to pick mosquitoes. Of course, the question is, was the number of mosquitoes affected by the amount of rainfall? So by default, if you ask Pandas to try and do a linear regression, it will do a linear regression where the line goes through the origin, which is not what you want. So in order to add a y-intercept, we have to use sm.add_constant. I'll show you now. So I'm going to use capital X, at the risk of confusing everyone, the sm, that's the stats models package. We're going to add a constant to little x. And we can leave notes to ourselves. Remember that comments in Python are with the hash. And then we are going to perform an ordinary least squares fit. So the this is what the syntax looks like. So we're going to fit an ordinary least squares line to, or do an ordinary least square fit. So again, we can leave a note to ourselves. We ask the model for its predictions, and then we want the model to print out the summary. So this is the piece of code, and if you go ahead and copy and paste this from the previous page, you will see you get something like this. Now, don't worry if you get this red box. In fact, I'm almost certain you will. We'll have a look at that in a moment. You'll see you get this big load of data. The piece of data that we want is here and here. These are the coefficients of the straight line that we could draw through it if we did the OLS analysis here. The red box is because it tells you kurtosis test is only valid for n greater than or equal to 20. Of course, data only has 10 data points, which is what it's telling you here. Because this big data box here also contains some kurtosis and skew measures and some other bits and pieces. However, we're only interested in these things here, and so the straight line that goes through the data points is 0.6592 times the rainfall plus 49.8. That gives you the number of mosquitoes. So these two things here. If you want to get them out, we can ask for model.params, and then if we want the rainfall coefficient, we ask for it like that, and if we want just the sort of the unit coefficient, then we just ask for const. Sorry. And there it is. All right, the final part of this course involves this project here, and specifically this Excel file exam results. So let's take a look at it, shall we? The Excel file is a set of exam results of physics students who took 4 courses, quantum mechanics, relativity, waves, and then lab work, which was more of a coursework module. And they took it over a year and then they got some marks for it. The Excel file, and you'll have to find which command you need to use in order to import Excel files, because it's not the same as the one for CSVs. The Excel file contains their names, the program that they're studying. Some of them are taking physics, some of them are taking physics with maths, with astrophysics, physics with languages, physics and cosmology. Some of them are on 3-year degrees, the BSc, some of them are on 4-year degrees, the MSci. Not all of them took all of the courses. You'll see that some of them have NAs in the box if they didn't take a particular course. You'll see a little hint on the GitHub if you go looking for it as to how to deal with NAs. And yeah, so every student belongs to a tutor group. The tutor group is down here on the right hand side. So some of the questions will involve the tutor groups, and you'll have to maybe group by that. That's there. So this is the file, and here are the questions. So imagine that you're the director of undergraduate studies. You have to do a few things. Firstly, you're going to give prizes to the 5 students taking physics. That's the physics program, so not physics with, but just physics, with the top mean marks over all 4 modules. So the question is, which students get the prizes? And then the staff member running the tutor group with the highest mean mark wins beer. So you have to figure out which tutor group that is. And then the questions continue down here, hopefully including everything that we've talked about over the last 2 sessions. So have a go at this. I don't expect you necessarily to be able to finish all of these. They get sort of increasingly more difficult and longer. So as I say, take your time, enjoy going through them. And I mean, this could take, I've had students spend more than an hour on these. So enjoy. And then when you're ready, come back and we'll wrap things up. So I hope you enjoyed doing those. If you're interested in my solutions to all of these questions, actually you already have them. In the folder that you downloaded, the examples folder, which included A1 and A2, the mosquito data, it also includes exam results project.py, and in here are my solutions to each of the questions, 1 down to 7 down here. So these are my solutions, and you can compare with mine. I'm not saying that mine is necessarily the correct way to go, it's just a way to go. So feel free to have a look and to compare. So that brings us pretty much to the end of the course, actually. I hope you enjoyed it. If I can ask you to head to the feedback form, which is down here, these sorts of courses are obviously, this sort of distance learning is new for us in the graduate school, teaching these sorts of IT courses. So your feedback is absolutely appreciated. It means we, the next time that we do this course, we can improve it and make things better for the next set of students. This material here is going to stay up for a long time. If you go to the GitHub here, the YouTube video should stick around for another month or so at least. So if you want to consult with it, you are absolutely more than welcome to. All right. Thank you very much for listening, and I hope you enjoy playing with pandas in the future.